start this. So this is f of x, and the first question asks, identify the zeros of the function and their multiplicities. So we learned this on Thursday. Can somebody tell me, you can chat it or you can come off mute, either way. Somebody tell me what at least one of the zeros is. What's one of the zeros? We were calling them roots on Thursday. What are the roots? -2 is one for sure. And there's one other.
Would it be 3?
It'd be 3. Yeah, for sure. Thanks, Mia. It'd be 3 here. Not quite 4, but it would be 3. So the roots are x equals -2 and x equals 3. What kind of root is at -2? Is it a single root, a double root, or a triple root? It's not a single root. It does this like flattening out business. It's not a double root. Double root would have to bounce back up. So what's the last one? Triple, yes. It is a triple root. The reason it's a triple root is because it comes down this way, it flattens out, and then it keeps going. It looks like a cubic function. So this is a triple root. So we would say that at -2, it has a multiplicity of 3. A multiplicity of 3. I abbreviate multiplicity with the n period. N period. Okay. So then it comes back up and it goes through here. Just goes straight through here. So would 3 be a single root, a double root, or a triple root? It would be a single root. Yeah, it'd be a single root because it just goes straight through there. So we could put multiplicity 1, but that's actually assumed. So if we just see x equals 3, that means it's assumed it's a single root. It's only important to write the multiplicity if it's not a single root, right? So this would be -2, a triple root, and a single root. Cool. So based on the number of zeros and their multiplicities, this is x to the power of 4, because I have 3, a triple root, and 1, a single root, and altogether that's x to the 4th power. So this is x to the 4th power because there are technically 4 roots. There are 3 at the same place and 1 additional one. Okay. So then if I'm going to write the equation, I would write, I want x equals -2, so it would be x plus 2, and there's 3 of them, so I'm put it to the 3rd power. And then I want x equals +3, so it'd be x minus 3. There's only one of them, so I leave it like that. So we could say f of x equals this thing. Okay. Privately message me on a scale from 0 to 5 how comfortable you feel. 0, I don't get this at all. 5, I feel like I could do this on my own. Blow up my chat, tell me where we're at. Seeing some 3s, 4s, 5s, 2s, 1s, 3s, 1s, 3s, 3.5. Cool. Okay, based on our, thank you for those numbers. Based on those numbers, I feel like it would be good for us to do another one. So let's do g of x really fast. Can someone tell me what are the zeros or the roots of g of x? What are the roots? -4 is 1. What else? 1 is 1. And 4 is 1, for sure. There are 3 of them, right? So I have x equals -4, x equals 1, x equals 4. Right? At this point, it goes straight through. That is a single root. At this point, it goes straight through. That is a single root. At this point, it goes straight through. That is a single root. Right? So at each of those points, we have single roots. So there are no multiplicities. So I would just write the 3 of them like this. So based on how many roots there are, zeros and their multiplicities, I would say that this is x to the 1, 2, 3, x to the 3rd power, x to the power of 3. All right. So based on this, go ahead and try to write the equation Go ahead and write the equation. You can type it to me. If you want to write it on your paper, you can. So the first one, I would say this is x equals -4, so I'd start with x plus 4. For the second one, I have x equals 1. Axel, I agree, it would be x minus 1. And then the last root, x equals 4, this would be x minus 4. Exactly. So they have each of these corresponds to one factor. Definitely. Thanks for those chats. Okay, that one was all single roots. This next one has no single roots. What are the roots here? What are the roots here for the zeros? -4, and +1, I am seeing Gali is telling me this is a double root here. What kind of root is 1? Triple. Yeah, Araceli, you're right. A triple, right? Good job, guys. It's a triple root there. So I would say that x equals -4 multiplicity 2. How would I write the other 0? X equals what? Yeah, x equals 1. Whoa, sorry about that zooming. X equals 1 multiplicity 3. Do be careful that you put the period there. And m by itself doesn't really mean anything, but m period is usually almost always multiplicity. So just be careful to put that like point there. Cool, good job. So then based on how many zeros there are, how many roots there are, what is this x to the power of? X to the power of, yeah, Fatima, good job, x to the power of 5. Because there is a double root that counts for 2 and a triple root that counts for 3 more. That's 5 total. Good job, y'all. All right, go ahead and try to write the equation for this. Try to write the equation for this. I would love to see it in the chat when you feel comfortable. Awesome. Axel, can you talk to us? Can you come off mute if possible and talk to us about your equation?
Yeah, I got x plus 4 root 2 and x minus 1 root 3. I got x plus 4 root 2 because the root with -4 is a double, so that's the squared, and the root with 1 was a triple, so you add a 3.
Yeah, absolutely. Thanks, Axel. Killed it. That's for Axel. Appreciate you. Sweet. Okay, now that we've done these examples, how are we feeling? Give me a fist of 5. 0, I still don't get it, Miss Mac. This makes no sense to me. 5, I get this 100%. Let's move on. 3, I think I get it. I'm still like thinking about it. 4, I'm closer to getting it. Some 3s, 3.5, 4s, 5. Oh, 6. Christine, big day. 6, 4s, and 5s. 4.8, I love that. So specific. How do you do the amount of multiples? Good question. So the amount of multiples is based on what kind of root it is. So if it goes straight through a point, like just straight through and continues going, it's going to be a single. If it bounces off of the line and creates like a little parabola that touches the x-axis one time, that's a double. And then if it does this thing where it's like coming towards it and then flattens out and then goes up, that's a triple. So the triple means 3, so that's the exponent 3, and double means 2, so that's the exponent 2. And then you don't need to do it for a single, it'll just be 1. So You don't need to write that one. Amazing question. Cool. All right, let's take some notes real fast. I know you guys are like, wait, we're not doing that yet. Well, we're gonna try something new. All right, so notes number 14, if you're putting in your notebook or trying to keep track, the title I would say is Graphing Polynomials. And I listed out the steps for us here. And the steps are also in your homework like 100 times on every page. So you won't be able to forget the steps. All right. I do want to apologize. There is one typo. So if you printed out your notes last night or early this morning, this -5 should actually be a -3. So when we get there, just make sure that you have the correct equation here. I apologize for that typo. Cool. All right, so the 4 steps are listed here. Number 1, we're going to factor if necessary. So if something needs to be factored, we'll break it down smaller. Number 2, we're going to identify the zeros and the multiplicities, like we were just doing. We're going to sketch a graph. That's number 3. So we're going to plot those points. And then we're going to label the y-intercept. So this is, we're going to decide if it's positive or negative. We'll talk about that when we get to step 3. And we'll talk about how to find the y-intercept. Cool. Okay, so first thing, we're going to factor if necessary. So here I see x plus 1 is hanging out by itself. It's fine. It's like in its smallest portion. But x squared plus 4x plus 3 can be broken into a factored version. So what multiplies to get 3 and adds to get 4? Three and 1. Absolutely. 3 and 1. Thank you. Thanks, Gally, for putting it in this version. X plus 1, x plus 3. Multiplies to get 3, adds to get 4, for sure, for sure. And then I'm going to bring down the x plus 1 here as well. All right. So you might notice that you could write this as x plus 1 squared because there are 2 x plus 1s. And then we also would have the x plus 3. That's like the fully factored version. So step 1 was to factor if necessary. Step 2, identify the zeros and their multiplicities. So what is the 0 that's going to come out of x plus 1? -1 for sure. And what is its multiplicity? Yeah, 2. Multiplicity 2 because there's a the square here is telling us it's multiplicity 2. There are 2 of them. Or we could see earlier we had 2 of them here. There literally were 2 of them. So that's how we got that. And then from here we have x equals with our other root, -3 for sure. Y'all were ready on that one. Good job, Layla and Kayla. And that is a single root. So we have a single root and we have a double root. So those are my roots and their multiplicities. So our third step is to sketch a graph. So I'm going to go to my graph and I'm going to say, okay, there is a double root at -1. Sometimes when I'm graphing, I put an X right here to show that there is a double. Christine, I see your question. Why did we not count the 4? This 4, we used it, this right here turned into this portion right here. Right, so the 1 and the 3 multiply to get 3 and they add to get 4. So this thing right here is the same as this version. I need to get them into parentheses that just have like x plus a number or x minus a number in order to be able to do the next step. So I broke up the 4 into the 1 and the 3. So that's why we're not counting the 4. That's a good question. Awesome, cool. All right, so we have -1, there's a double root there. I was saying that I put an X right here to show that it's a double root, but that's not like a mathematical thing. I just put it there to remind myself that it's a double. Some people also put like a D next to it to remind them that it's a double. You can decide what you want. And then there's also -3, which is a single root. So you can put an S next to it if you want. All right, so how we know if it goes up or down is if the equation overall is a positive value or a negative value. I'm going to clean this up just a little bit here. So if you imagine, and we can actually do this if it will help you. If you imagine that we're multiplying these two things together using either FOIL or the box, right? We're doing x squared plus 4x plus 3, x plus 1. The biggest thing always ends up here. And by biggest, I mean the highest degree ends up there. So this would be x to the third. And the constant term always ends up down here, as long as they're in the right order. So 3 times 1 would be 3. So since this is positive, since it's positive x to the third, not negative x to the third, that means that this is a positive graph. And as you remember from your positive graphs, they end going up, right? They end going up. So I'm going to go to my furthest point and I'm going to make my graph go up like that. Right? So since this is positive, overall positive, x squared times x will be x to the third, right? Since it's positive, it's going to end going up. And from there, I can go ahead and draw the rest of my graph because I know this is a double root, so it's not going to go, it's just going to bounce through that. And then it has to go through -3, and that's a single root, so it keeps going through like that. So I can see that positive shape. I can see the positive going up at the end. I can see that cubic shape, the like 3 direction. And that's how I can show my graph there. And then finally, I'm going to label the y-intercept. And the y-intercept is always the constant term. It's whatever, if you multiply just the numbers, the constants by themselves, then you will find out what the y-intercept is. So in this case, if you took +1, +3, and +1 and multiplied them together, you would get your constant term of 3. You can also do it with the earlier part. So +3 times +1, the y-intercept is 3. If you wanted to do it with this version here, you'd have +1 times +1 would be 1, times +3 would be +3. So that is how we find our y-intercept, a y-intercept of 3. Do I have a super brave person or like person who feels like they get it to explain how we know if the graph is positive or negative? There's someone who understands and could put it in a different way. Well, how do I know that it's positive or negative? Okay, good. Let me explain it again then. So if we, the only way that it would be negative is if at the beginning it said -x to the third plus 2x squared, blah, 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 whatever it says after that. If this negative is here, that means that after the last point, it's going to be headed down, right? So from that last point, it's going to be headed down. If there's no negative there, then it will be headed up at the end. So if it was x to the third plus 2x, whatever, right? Then since this is positive at the beginning, then from the last point, it would be headed in the upward direction. Thank you for that question. Is there another way to identify that it's positive? Not particularly, no. So we need to know if it, I mean, if it looks like this, we know that it's positive because there's not a negative right here. If it looks like this, we know that it's positive because there's not a negative right here. If it looks like negative x minus 4 times x plus 2, then it is negative. It's going down, right? Most of our graphs are going to be positive today. The only way that it could be negative is if it has that negative in front. Can there be other negatives in the equation and it still be positive, or does the first negative determine that it's negative? Oh, good question. Okay, so let's say, you don't need to write this down unless you feel like it's useful to you, finding a small area. Okay, let's say that it is, oh, let me wait for my thing to lag. There we go. Okay, let's say that it's negative x minus 3 like this, right? This would be a negative graph. It's going down. Let's say that it is just x minus 3. This is a positive graph. Overall, the graph is positive because there's a positive here. This negative inside is not impacting the direction of the graph. Okay. If it was 3 minus x like this, the x is negative. The x is negative. So actually, we would need to write this as negative x plus 3. And that is a negative x, right? So this negative x, we would need to factor out the negative. So we're basically like dividing by -1, like that. So I'd have -1 x minus 3. So now this right here is a negative graph because of that -1. Right, so if there is a negative x, it's just a negative x. It's not a negative number. I guess that's a good, better way to explain it. So like this -3 doesn't impact it, but a negative x does impact it, right? So at any type of negative x anywhere in the problem, if there's a negative x, it's going to be a negative graph. Is that making sense? I know I've said a lot of negative and positive. Maybe. Okay. Making more sense. Off topic. Did I cut my hair? No. Still super long. Cutting it soon. Okay. Let's. Thank you for letting me know that it makes sense. Peeps in the chat. Yes. Let's try another one, and I will continue to work with you on positives and negatives. That's a great question. Okay. So let's try this one. The first step is to okay, wait, let's go back to this last one because we are asking a great question. So the first thing we did was we factored it if we needed to. And the second thing we did was we found the roots. The third thing that we did was we graphed the roots and we determined if it was positive or negative. So if positive is going up, and then we traced through the rest of the graph. And then the last step was to label the y-intercept. And I did that by multiplying the numbers, the constant terms, by themselves. So 3 times 1 would give me 3. Okay. So for this second one, I'll give you a second to write it down if you need to. For the second one, we have x plus 2 to the third and times x minus 5. So we have what kind of root is coming out of this one here, the x plus 2 to the third. Yes, a triple root, so -2m3. And what is coming out of the second one? Triple. Yes, 5 multiplicity of 1. So again, we don't need to write the multiplicity of 1 because it is assumed that's a triple, or I'm sorry, a single for sure. So we have a single root. So wait, we have a triple root and a single root. So I'm going to go ahead and graph them at -2. I have a triple root, or mark it with a T. At 5, I have a single root, mark that with an S. Is this graph overall positive? Like all the x's are positive? or are there any negative x's to make it a negative graph? Positive, yeah, it's positive. So there's no negative out here, that would make it negative. And there's no negative x's in our factors, that would also make it negative. But since everything is, all the x's are positive and there's no negative in front, that means that it's positive. So our graph is going to be headed up at the end. This is a single root, so it's going to be going down all the way through that. Nothing, no funky business happening there. And then it has to go through that triple root, so it's going to come back down here. And then remember, a triple root looks like a cubic function, so it's going to like basically go like this, flatten out, and then go up like that. Doesn't need to be perfect. You can graph it just like this. For sure. Cool. Okay, so we found the roots, we graphed it real fast. And to be fair, we're not really graphing, we're sketching. That's why the y-axis doesn't have any numbers on it, so that we can write the y-intercept, whatever the y-intercept needs to be. What would the y-intercept be in this case? What would the y-intercept be? I'm seeing -10, but question marks, we're not quite sure. And lots of -10s after I said it out loud. Yeah, here's the thing, it's not -10. It's actually negative. Wait, let me think. It's actually -40. It's actually -40. Does anyone have any idea why it is -40? Aha, because of the cube, because 2 is cubed. Yeah, so technically, while we wrote it in that fancy way with the exponent, this technically means this. So we're really doing 2 times 2, which would be 4, times 2, which is 8, times -5, which is that -40. Right? So because it's cubed, that matters. In the last one, because it was 1 being squared, it didn't actually matter that much, because 1 times whatever it is not changing the problem at all. Right? But since it's 2 being squared here, that's going to dramatically change the answer. So it'd be 2 times 2 times 2 times -5, like that. For sure. What, if any, questions do we have about this one here? If you don't have a question, if you have a question, keep typing. If you don't, go ahead, take a moment to write down this problem here. Remember, this is our typo problem. I'm erasing. All right. Okay, seeing no questions, I'm going to give you a moment. I want you to go ahead and do step 1, which is factoring, since this one is in 4. Oh, we did have a question. So if it's a double root, it wouldn't be the same thing, just do it twice. So if this was a double root and there was 2 of them, you would just do 2 times 2 times -5 rather than times the third one. So it would be the same. So 2 times 2 times -5. Does that answer your question? Sweet, awesome. Okay, so for this one here, you're gonna go ahead and start by factoring. Remember, step 1 is to factor if necessary. This is definitely necessary. Go ahead and try to factor it. We'll come back in a second. You need a hint to get started. There are 4 terms. So you're going to cut them in half, take the GCF of each pair. So from the first one, I can take out x squared. That leaves me with x plus 2. from the second one, I can factor out -3. Down leaves me with x plus 2. Since these are in common, I can factor it out of the entire thing. So the x plus 2 and left over x squared minus 3. All right. Is 3 a perfect square? Is there anything we can do with that? Like, can we break it down? No, it's not a perfect square, right? We have 4 is 2 times 2, but 1 is 1 times 1. So nothing we can do there. So we're going to find our roots here. This root is going to be x equals -2, multiplicity 1, so we don't need to write that. And then this one over here, I actually have to set it equal to 0, like super old school. Set it equal to 0, move that 3 over, x squared equals +3. Take the square root of both sides. You get x equals number positive or negative square root 3. So you actually have, it's not multiplicity 2, it's actually 2 separate answers. It'd be positive square root 3 and also negative square root 3. If you prefer to work with decimals, I totally get you. Me too. That would mean that we have square root of 3. Whoa. Square root of 3 would be 1.73 and negative 1.73. So we have 3 single roots here. 3 single roots. All right, I'm going to go ahead and plot them on my graph. I have -2, 1.73, and negative 1.73 right there, close to -2. Is this a positive graph or a negative graph? What is the leading term? Is the leading term positive or negative? Positive, yeah, it's positive. And I know that because it doesn't say negative x3 at the beginning. So it's positive, so I know it's going to be headed in the upward direction. Each of these is single roots. So I'm going to go ahead and go single root, single root. It has to come above here and then single root again, right? So notice it kind of looks like a double root, but it actually goes through both of them as single roots. And then my y-intercept is going to be the constant term. It's this number right here, the number at the end, will be -6. Notice you could multiply +2 and -3. You would also get -6. So -6 is your y-intercept. All right, team. Just in time, we've made it to the end of our notes today. That is the end of our notes. You guys did an amazing job answering and asking questions. Really super proud of you. Your homework tonight is going to be, it is on Decima. The assignment is both in Canvas and posted at the bottom of the notes. You'll see on the assignment that there is a link to Decima. And then both on Canvas and in the notes, you'll see that there is a link to a video. I went through, I think I did 3, maybe 4 problems. I did 4 of them on a video. So if you're getting stuck on any of the problems today, I made that video so that you would have access to like more additional support from me. Okay. I unfortunately do not have office hours today because I'm going to professional development for teachers. It's like how I become a better teacher. So if you would like any like support or help from me, just shoot me a text message. I'll still be like available later on tonight, and I'll be able to like message you back or take a video of me explaining the problem. So if you have any questions, please let me know. I also have about 10 more minutes before I have to go to that today. So if you want to stick around and ask any questions, I'm happy to answer them. Thank you, guys. Let's do one final fist to 5. for how we're feeling on this topic. One final 5th to 5. Fatima, no, we're not going to submit the notes. Good question. 3.14, you're feeling pi. Feeling 4s, feeling 5s, feeling 4s, 4s and 5s. I'm here for 4s and 5s. Amazing, Devin. I'm so glad you feel better. I'm glad we're seeing 4s and 5s. If you're a 4, you're getting lots of practice tonight, and I will be watching you. So I'll try to reply back to your desktops if I see you starting to go the wrong direction. So you guys will be great. If you're feeling like a 4, I think a lot of practice will help. If you're feeling like a 5, practice will be awesome. I'm so glad. Thank you for that, Mia. Awesome team. All right. If you need any more support, please let me know. Otherwise,